Hi everyone, in this video we're going to go through completing the square. So basically it's just another way of factorizing monic quadratics, and we also use completing the square to get a quadratic in what we call turning point form, which we'll probably look at in a bit more detail when we do graphing. And it also helps us with our transformations, which is probably a bit beyond what you're going to do in year 10, but completing the square is extremely helpful. So the reason we complete the square, I guess, at this level is when our monic quadratic isn't straightforward. So what I mean by that, if we have a look at 4a, sorry, I'll just get my pen. If we look at 11 and 6, so remember when we're factorizing monic quadratics, we need two numbers that multiply to give us 11 and add to give us 6. So the only factor pair of 11 is 1 and 11, and obviously adding them together doesn't give you 6. So we're going to have to complete the square, and then we factorize if we can. So it says if possible, and I'll explain what that means when we've actually completed the square. So first of all, if you get a monic quadratic, just remember you might not always be able to factorize it using the method of finding two numbers that multiply to give you 11 and add to give you 6. So you can complete the square. Or you can use the quadratic formula as well, which I've mentioned to you before, but I haven't yet shown you. There's a bit of theory here. Now, I would probably say don't write it down, only because there's a lot there that might not make a lot of sense until I've actually explained it to you. So copying it down is, there's a lot there, and I'm probably going to simplify it for you. So, you can write it down if you like, but I'm going to just explain first of all what it means by completing the square, or why it's called completing the square, and then we'll do some questions, and then you can choose what you want to write down in your theory. All right, so let's think of a square. Now, obviously, it's not going to be the best square, and the length of the sides of that square is x. So the area of that is x squared. Now, if I was to extend the sides by maybe 4. So the square's been made bigger. That means this side here is x plus 4. Okay, so the whole distance, we initially had x and then we added another 4. And this side here is also x plus 4. So your area of that bigger square is x plus 4 squared. Now, if we were to expand that, so remember the opposite of factorizing is expanding. So when we're factorizing, we're given the expanded form of the quadratic. So I'm going to expand this and then show you the relationship between the square. All right, so we're going to have x squared plus 8x plus 16. Now, that's a perfect square, so I already knew the rule for that. If you don't know, you can just use FOIL because it's the same as that. All right, so x squared plus 8x plus 16. Now, what you'll start noticing when we do completing the square is the coefficient of x, which in this case is 8, is double, what are we going to do? Double this number here. Okay, so they're important to note. All right, the 8 and the 4. And when you think about it, 16 is 4 squared. So that the relationship between those three numbers is extremely important when you're completing the square. All right, so the 4, or whatever that number is just half your coefficient of x. All right, so again, still probably not fully have grabbed you just yet. So let's do another example just to show you that that works. All right, we'll do this one in pink. So let's extend it this time maybe by 3. All right, so the area of that one is x plus 3 squared. So when we expand that, we get x squared plus 6x plus 9. Okay, so the relationship between those two numbers, or the three numbers. Okay, so notice that relationship. So we're going to use that knowledge to complete the square. All right, so let's just say I was going to, if I had a quadratic that was x squared plus, let's go down and do 4a actually. It's probably the easiest way to do it. 4a, x squared plus 6x plus 11. Now this one is a little bit different because, it's not a perfect square like these ones were. So that would have been easy. But what we're going to say is, all right, let's just pretend that we're going to make it a perfect square. So I'm just going to deal with these two numbers first. So x squared plus 6x. So what would I add to make that a perfect square? So if you go back and think about what we did here, all right, what was the relationship between the 4, the 8, and the 16? So basically I want to add something on, all right, to complete the square. So you can see we've got x squared plus 6x, which is what we're going to have in 4a. So we're going to add on 9. But basically, to get that 9, we're going to take the coefficient of x. So x divided by 2, sorry, not x divided by 2, 6 divided by 2, and then we're going to square it. So we've got x squared plus 6x. 6 divided by 2 is 3. 3 squared is 9. So we've actually now, we can, go away. We can complete the square. So that is the same as x plus 3 squared. Okay, so that's what it means by completing the square. The only problem though is, well, we've got this 11 on the end, and I have changed that quadratic. It is no longer x squared plus 6x plus 11. I've changed it to this, x squared plus 6x plus 9, and I can't do that. I can't just change something. So if I've added this, the 6 on 2 squared, that means I need to also take it away. All right, I just can't add something. All right, otherwise it's not equal. All right, what I've got at the start in pink is not equal to what I've pointed to here with the green arrow. So I've got to subtract it. And then don't forget, we've got that plus 11 on the end. So now I haven't actually changed my quadratic, because when you think about this part here, it's equal to 0. I've added 9 and then I've subtracted 9. But the reason why I've added 9 is so I could get that square. But then I've still got to, put this part on the end. So then I've got minus 6 over 2 squared, which is 9, plus 11. So I'm just going to tidy that up. X plus 3 squared minus 9 plus 11 is plus 2. So that's what it means by completing the square. You want to have this part here, you're completing the square, and then you're going to have some constant. So it's going to be minus or plus a number. All right, so every time you do it, if you didn't have a plus or a minus a number, that means it would have been a perfect square to begin with. All right. Now, in general terms, let's just say, and I might continue this, let's just say we had a general quadratic. Okay, so x squared plus bx plus c. So b and c can be absolutely anything. My coefficient of x squared will always be 1, all right, when I'm completing the square. So we're just going to look at different values of b and c. So in general, when you've got that, if you want to complete the square, you're going to do x squared plus bx, and then you're going to add b on 2 squared like we did before. Then you're going to subtract it, because otherwise you've changed the value of that quadratic, and then you're going to add c. Basically, when you bring that all together, you're going to have x squared. Whoops, no, you're not. Not squared yet, sorry. You're going to have x plus b on 2 squared, whoops, minus b on 2 squared plus c. So this part here is what you can always just substitute B and C into. All right, the second line, this one here, is basically showing you where it's come from. All right, but if you want a little shortcut, then you can just do what I've got in that green rectangle. All right, so let's do some more examples. Now, with 4a, just for reference, we can't factorize that any further, and that's because of this plus sign. All right, and I'll explain that when I do one with a minus sign. I'm just trying to think if there's any there that might turn into a minus. All right, the next one's going to be a minus, I think. All right, so I'm going to just get rid of that because it's taking up a lot of space. We'll do question B here. So x squared plus 4x plus 7. All right, so I'm going to do this the same way as I did the previous one, and then I'm going to use the shortcut, which is what I've just put in this little green box. All right, so I'm going to do another one with the full working, and then we're just going to go straight to this little green box. All right, so we've got x squared plus 4x. All right, then we're going to add the coefficient of b, so 4 on 2, and we're going to square it. And then because I've added something that wasn't initially there, I'm going to subtract it just to make sure it stays the same value. And then we're going to add 7 because 7 is here. All right, so to complete my square, if we just look at these first 3 terms, all right, I've got x squared plus 4x. Now 4 on 2 is 2, 2 squared is 4. All right, so when I'm factorizing that, I'm going to end up with x plus 2 squared. But I can't forget this other stuff. So I've got to subtract 4 on 2 squared, which is 4. Oh, this is going to give me a positive one as well. All right, and then we're going to have plus 3. So on the end, I've got x plus 2 squared. I'm just going to write that again in black, plus 3. So again, I can't factorize this any further because of this plus sign. Sorry, I thought it was going to turn into a minus. All right, the next one should be fine, I'm thinking. So let's do question C, and then I'll show you what it means by we're able to factorize further. So obviously, if I'm going too quick, you can pause. So I'll just scroll back up, pause it if you need to. All right, x squared plus 8x plus 1. All right, so this time I'm just going to jump, and I know this off by heart, so I'm not going to keep scrolling, but I'm going to identify B and C and just substitute it into this little green box. All right, so for this question, and I'm just going to write B and C underneath those values. So B is always your coefficient of x and C is always your constant. All right, so we're going to start off with the x, then we're going to add B on 2. So b over 2, 8 divided by 2 is 4, and then we're going to square that. And then I'm going to subtract b on 2 squared, so 8 on 2, which I know is 4, and I could have done that all in one go, and plus 1. So let's just tidy that up. So I would eventually just do 8 on 2 squared, which is 16, plus 1. So a lot of working here I probably wouldn't do, but just because we're still learning, we'll do it all. All right, so what we've got here is a minus sign. So that sign, so here we had a plus, here we had a plus, and here we had a minus. That sign is extremely important. It tells us whether we can factorize it any further. So what it means by factorizing, we're just going to look at a little bit of a graph for now. So a quadratic has a graph, like a linear graph is a straight line. A parabola is like the shape of a U. So parabola looks like this. When we're factorizing it, it helps us find where it's crossing the x-axis. So we can see here, all right, it's crossing 2 spots. Now, if you couldn't factorize that, like in the first 2 examples with the plus sign, what that actually means is your parabola isn't crossing that axis. All right, it doesn't have any x-intercepts. You could have a positive parabola, which is a U shape, or you could have a negative parabola, which is an upside down U. And also this one doesn't cross the x-axis. You could also have a parabola that just sits on the axis. So it only has one x-intercept. But when we do graphing, we'll explore that in a little bit more detail. So basically, we can't factorize this any further if there's a plus sign there. Now, to factorize it, we use difference of perfect squares, so DOPS. Now, remember difference of perfect squares, which we've done quite a bit. A squared minus B squared equals A plus B, A minus B. All right, so we've done a few of them. Now, the reason, if you think now, this is plus, this is a plus. Remember the D stands for difference. Difference is minus. All right, so if I said, what's the difference between the numbers 20 and 25? You'll say, all right, so that's 25 minus 20. All right, so when we hear the word difference, we're subtracting. So there has to be a subtraction there for you to do difference of perfect squares. So for this one here, let's go ahead and do it. So we've got x plus 2 squared, sorry, x plus 4 squared minus 15. So in this question, if we're doing DOPS, so this is a different b, which is a little bit annoying, is x plus 4, and your b is the square root of 15. So we just got to leave it as a surd. So we're going to have, so I'm just doing this part now, x plus b, so x plus 4 for a, plus b, which is root 15. And then a minus b, so a being x plus 4, and then minus square root of 15. So now we've factorized it. What those 2 points actually indicate, if I go back to my parabola crossing my axes, they help us find those 2 points. All right, that's why there's two different versions of them. All right, let's move on to question 5. So we're going to still do completing the square, but this time it's a little bit different because you'll notice before we were dealing with even numbers, which was pretty cool. But now we're going to deal with odd numbers. So even numbers, it just means we're going to be always dealing with integers, but now we're going to be dealing with fractions, which is okay. All right, so let's start with 5a, x squared plus 3x plus 1. All right, so identifying b and c. So b being your coefficient of x and c being your constant. Now, we're going to do a lot with quadratics, and we usually have an a in front of the x squared, but because it's a monic quadratic, the value of a is just 1, so it doesn't matter. But when we use the quadratic formula, you're going to use a, b, and c. So the same a, b, and c. All right, so starting off with completing the square. So x plus half of the coefficient of b, which is 3 on 2. All right, so before, that's what I was saying, we were dealing with even numbers, which nicely divide by 2, but now we're dealing with fractions. Now, in methods, just leave things as improper fractions. Don't go writing that as 1.5, don't go writing that as 1.5, leave it as 3 on 2. The reason for that is because it is so much easier to work with improper fractions than what it is to deal with mixed numbers or decimals. Okay, so we're going to leave it as 3 on 2 squared, and then we're going to subtract 3 on 2 squared, oops, plus 1. All right, so let's just tidy up that constant. So we've got 3 on 2 squared. When you're squaring a fraction, you square the numerator and you square the denominator. So we're going to have 9 on 4. All right, so 3 squared is 9, 2 squared is 4. Now, the 1, because we're eventually going to be adding it, if you're adding fractions, it's always a good idea to have the same denominator. So 1 is the same as 4 on 4. All right, so minus 9 on 4 plus 4 on 4. So it's going to be minus 5 on 4. Just make sure that's right. And then because there's a minus sign here, we can factorize it using the difference of perfect squares. So your value of a, now this is a different value of a and b, which is a little bit annoying. You'd think they would use different letters. And b is the square root of 5 on 4. Now remember, we can write that as, which is root 5 on 2. Okay, so we're going to have x plus 3 on 2, so a plus b. So there's your a plus b, which is root 5 on 2. And then we're going to have x plus 3 on 2 minus root 5 on 2. Now, because you've got the same denominator, we really should put them over the same denominator. So just adding those two fractions together. Now you'll notice they're quite symmetrical in their nature. Actually, what did I just do? Did I do anything wrong there? No. Like in this case, you know, the only difference is the plus and the minus. It's because a parabola is symmetrical, and which we'll, you know, look at in more detail when we do the graphs. All right, let's just do one more. So I might just do e. So what is it? Minus 3x plus a half. Just going to make sure I've written that down correctly. X squared minus 3x plus a half. All right, so b again is your coefficient of x. Whoops, I might do that in black so it stands out a little bit more. Now in this case, and I think this is the first negative one we've done, b is negative 3, which is fine. It just means when we're substituting it in, it's going to be minus 3 on 2. And then we're going to have minus. Now be consistent with your negatives. So we're always going to have a minus here. And then your, because your b is negative, just make sure that goes inside your bracket as a negative, plus a half. All right, so negative 3 on 2 squared. When you're squaring a negative number, it does become a positive. So that's going to be 9 on 4. And then a half can be written as 2 on 4. All right, so minus 9 on 4 plus 2 on 4 is minus 7 on 4. And because of that minus sign, we can use difference of perfect squares. So in this case, a is x minus 3 on 2. And b is the square root of 7 on the square root of 4, which is 2. And let's just, there's a plus b. A, make sure you're consistent. A bit squishy there. With your, if you take your time, you're just copying this whole thing here. So make sure it's x minus 3 on 2. All right, let's tidy that up. Put everything as the one, over the one fraction denominator. So 3 plus root 7 on 2. And then we've got x minus 3 minus root 7 on 2. All right. Now we're just going to do one from question 7. I'm going to do G. Now you might be thinking, all right, these are non-monic quadratics because the number in front of x squared is not 1. Well, remember, if you see a quadratic that has a coefficient of x squared that is not 1, see if you can take out a common factor. Now we do want x squared always to be positive 1. So let's take out negative 4 as the common factor. If I took out 4 as a common factor, it means I'm going to have to factorize with a negative x squared, which isn't ideal. So taking out negative 4 as your common factor, that means we're going to end up inside with minus 3x minus 5. And you can always check by just doing a quick expansion if you like, especially if you don't have confidence. So -4 times x squared is -4x squared, -4 times -3x, so a negative times a negative gives you a positive, so 12x, and -4 times -5 is positive 20. All right, so that -4 just stays out the front. Now I'm going to use square brackets because things are going to get a little bit messy. All right, so let's just rewrite this. Oh, I don't know why I'm writing it again. All right, so there's your B and there's your C. So we've got a few negatives here. So let's just take our time. All right, so your value of B is -3. So we're going to have -3 on 2 all squared. Then we're going to have minus -3 on 2 squared minus 5. All right, the reason I'm using a square bracket is because that -4 is multiplying everything inside, and I'm already using round brackets or curved brackets. So I just want to kind of keep my brackets separate. All right, so x minus 3 on 2 squared, and then we've got -3 on 2, which is 9 on squared is 9 on 4, and then minus 5, so that's going to be as a fraction with a denominator of 4 is 20 on 4. All right, so we've got -4. Let's keep going. Did we get that constant sorted? All right, so we've got -29 on 4. And because we've got that negative, we can do difference of perfect squares. So I'm going to keep that 4 out. All right, I made a mistake, so I had to just erase something. So your value of A is x minus 3 on 2. Whoops. Actually, I might leave that in brackets. Plus root 29 on square root of 4, which is 2. Actually, I don't need... I'm going to put that in there, sorry. And then we've got x minus 3 on 2 minus square root of 29 on 2. And end with a square bracket. So let's just tidy things up again. Now I can get rid of my square brackets now because it's everything inside the brackets being multiplied. I'm just going to tidy it up so our two fractions are over the same denominator. And there you go. So those question 7 and question, what was that, 5, quite tricky with the fractions in there, but the method is exactly the same. All right, so if you practice the method over and over again, you should be able to do these types of questions. All right, girls, bye.